Solve the proportion. We can cross multiply to turn this into a problem that looks more familiar. 81 times 2 is 162, and 18 times x is 18x. Then we can divide both sides by 18 to solve it for x. 18 divided by 18 is single x, and then 162 divided by 18 is 9. So here we have 9 for our x value. You can cross multiply here. You'd get 28x, and 7 times 4 is 28, and then solve it for x. Consider the line graphed in the coordinate plane. What is the equation of the line? Well, it is a straight line going through the origin, so it follows that same pattern of y equals kx because it's proportional. But k is the unit rate, and in this case, k is going to be replaced with the slope, and the slope is represented by m. We also know that the point 1, k tells us the unit rate, so if we have 1, m, the k can get replaced with the letter m. So the equation is y equals mx. It's a proportional line, so it follows that pattern, y equals kx, and the unit rate is the slope. Explain how to use slope triangles to confirm your equation from problem 1. Well, if we created a slope triangle here, the height is m, and the base is 1, so the ratio would be m divided by 1. If I created another slope triangle somewhere else down the way, this would be x, and the height would be a height of y, so the height to base ratio would be y divided by x. So we can cross multiply here. M times x is mx, and 1 times y is y. For problems 3 and 4, write the equation of the line. Again, we're proportional. It's a straight line through the origin, so we're using that template, but we're replacing the k with the slope. So in this one, the height to base ratio is 4 to 2, up 4 over 2, which is a slope of 2. So the equation for this line is y equals 2x. This one has a negative slope because it's a falling line. We went down 2 and over 3, so it has a slope of negative 2/3. So the equation will be y equals negative 2/3 x. For problems 5 through 7, graph the equation. Well, we know that they're going to start at the origin because they're in that format. And it has a slope of 1/2, so we're going to go up 1 and over 2. And then we'll draw a straight line through those points. This one also starts at the origin, but this one's going to go down because it's negative. So down 4 and over 3. down 4, and over 3. We're always moving left to right. This one starts at the origin again, because it's in that template, y equals kx. And the slope here is -1. There's an invisible 1 in front of that x. And remember that whole numbers have that invisible 1 underneath. So this is -1x. So we're going down 1 over 1, down 1 over 1, down 1 over 1. This one says a new form of an equation of a line. The last ones are all passing through the origin, but this one is not. It says use slope triangles to find the equation of the line. Well, in the x direction, we went from 0 to 1, so that was a change of 1. And in the y direction, we went from 5 and 3, so that's a change of 2. The height to base ratio is 2 over 1, which is a slope of 2. But if we wanted to use another slope triangle from here and set up equivalent ratios, like we did in the last example, this would be x, and we started at 0, so that's a change of x. Here this measurement would be a y, but we didn't start at 0, so we're looking for the difference between y and 3. So this would be y minus 3, and then over x, the height to base. Then we will cross multiply. 1 times y minus 3 is y minus 3, and 2 times x is 2x. So this is an equation, but typically when we're writing equations, we want it to say y equals and then the rest on the other side. So we will add 3 to both sides, and that will give us y equals 2x plus 3. You can't combine the 3 with the 2x because one of them is a variable and then the other is just a regular number term. You might notice that the slope was 2, and it still shows up in the same spot. If we had that y equals kx equation, the slope still shows up in the k position. Then we have a new term, this plus 3. Where do you see the 3 represented in the graph? Well, that is the y coordinate of this point. It's where it started. Instead of at the origin, it starts up at 3. That is called the y-intercept. It's where it crosses the y-axis. 9. The line graphed in the coordinate plane has a slope m. Explain how to use slope triangles to find the equation of the line. Well, we're going to start by comparing two height to base ratios from two slope triangles. So I have a slope triangle here, and then we'll draw another one further out. This has the coordinates x, y. So if we're finding the difference of the y values here, y minus b, would give us this distance here. And then if we were finding the difference in the x values, remember like we did x2 minus x1, this would be x minus 0, which is just x. This one has the coordinates 1, and then we've got to figure out what this piece is here. We know that this slope triangle has a distance of 1 going this direction, and so up it should be a slope of m. So we'll have m over 1. So this has a height of m, but it also has that b piece in there. So this is going to say m plus b. This distance here is b, and then this distance here is m. Then we will cross multiply. M times x is mx. Y minus b times 1 is just y minus b. And then again, we move all the things over to the other side. So this will say y equals mx plus b. So after we compare the slope triangles, we cross multiply and solve it for y. So in this equation template, the m stands for slope, and the b is where it crosses the y-axis. It's called the y-intercept. For 10 and 11, write the equation of the line. Using that template, y equals mx plus b, we need two details. We need the slope. So we went up 2 and over 5. So this one will say y equals, and the slope will say 2/5 x plus, and then the b value is where it crosses the y-axis, which is at 3. And this one, the slope is negative because it's falling down as we move from left to right. Looks like there's a point here and a point here, so it goes down 4 and over 1. -4 divided by 1 is a slope of -4. And it crosses this y-axis down here at -7. So instead of it saying plus -7, we can rewrite it as y equals -4x minus 7. We're going to start at the y-intercept, which is 2. And then we're going to move according to our slope, which tells us to go down 5 and over 3. Down 5 and over 3. And then we're going to put a line through those points. For this one, we're going to start at our y-intercept. That is -3.5 or -1.5 if you changed it to a decimal. And then it tells us to go up 4 and right 1. So this would be 1/2, 1.5, 2.5, 3.5, 4, and right 1. start at -1. And this one tells us go down 5/1. Down 5/1. That's all for lesson 20. We'll continue working with this format, which is called slope-intercept form, and other forms of equations for lines in upcoming lessons.